Welcome to part 14, I think, of our Enderwire build series. We left it in a printable state last time, or actually like the time before last. Yeah, I'm streaming. And last time we struggled a lot with the input shaper, which I actually figured out like 30 minutes after the stream ended. Like we also had some technical difficulties, which I hope we don't have today. But we're also really reliant on the browser today. So even if that starts like acting up again, not a big deal today. Yeah, so we started with the input shaper. I managed to get it work with exactly what I did at the end. So using this external mainboard basically as a MCU and clipper, and then just having the very short cable run. But we will do this again today. So I'll just show how it worked in the end for me. Because today we will work on the belts, and if we change the belts, then we also have to redo the input shaper. So let's take a look at this beautiful desk here. I'm not quite sure what we will do first. We have very long to-do list, and I don't think we will get it all done. So we're kind of now in the make it pretty phase. So there's one mod I want to do for like how well it works kind of like change, and this is the change of those idlers here basically, or the motor mounts of the A and B motors. I can show that. I'm making a mess. Let me quickly show this. So basically my problem here with those original ones is that they are not constrained from like tilting. And I found more than once that one of the motors was like slightly tilted, and then basically like it doesn't, like the belt rubs against the pulley. The main difference, or the only difference with the new ones, is that they have like mounting hole here, where basically we can use a T-nut in the back and a short M5 screw just like to constrain this from tilting forward. This is the only thing this makes, or like does differently than the ones we have here. Besides this, the whole mechanic's the same. It's just like that it doesn't do this anymore. So it's just like more constrained. Given that this was something I found on printables, I am most likely not the only one having this issue. So it's really just like a really simple change. It's the exact same function. It's just like with this extra tab here on the back. I'm actually not sure if I would have needed to reprint the front parts. It's like maybe something we can quickly test. But yeah, so those we will exchange, but that's not the only change we'll do on the belts. We also will change the, I'm not sure how to call them, like the top part basically. The reason is that we will integrate these two LED bars basically. This is a part I already had on the Ender. So it's not something I got new, I just reused what I have. It's from IKEA, as you can see. I'm not sure if they still sell it. I didn't see it anymore. And it's called Dioder, which is like super simple LED bars, basically. Comes in, or came in a pack of 4, so I have 4 of those bars. We will need to work on this a little bit. So basically it has this like plug system here. And as it is 5mm too wide. Like this entire like setup is just 5mm too wide. So we'll have to like work a bit on the end caps just to make them shorter. As I stated, I noticed that I forgot to put out the saw. Let's see, if we need a saw, I quickly have to grab one. But yeah, there's a lot of plastic here. You can, let me get a little bit closer even. You can see like there's a lot of like potential to just make it a little bit shorter. So basically my idea is just like to cut off this entire like section that exceeds the PCB. If we do it on both sides, we should be already at our like length goal. And given that this is kind of like nested in here, like yeah, there's not too much that can go wrong. At the moment, it's of course like a loop. So at one side we don't have this loop, but like we just like route the cable out. And then my goal is basically to just route the cable on the back. Yeah, so these are the LED strips. It's just like I constantly find myself wanting to have some illumination of the build plate. And I think this is a nice setup. Like I designed those myself just to have some light on the print bed, but I still want to keep the appearance of the printer really clean. And now DHL arrives. 1 second. Optimal timing. They couldn't have been here like 5 minutes before. Cool. Yeah, so that's basically the top illumination, just for the print bed. So this is more functional. I wonder whether we should start with that, to be honest, because this is like a need I have when using this printer. So most likely we start with this entire thing. We have to get off the belt for both of them, so I just do them in one go. But we have more. So yeah, firstly, I have a new stealth burner front, and some people might know it, but this one is the stealth burner cover for the Nomi, which is this little display. It's from Big Tree Tech. So basically this goes just here in the front, and it, yeah, just goes in front of the fan. The fan has like those openings on the side. In a good old manner, everything is black, so you don't see it, but yeah, there are openings on the side now. So the fan goes behind that. And we will just connect that to the toolnet board, and this will have a little bit screen here, showing like a face for the printer, and also showing like the print progress, temperatures, and stuff like that while you're printing. So I won't have like a big screen in the front. Like this will stay basically as it is. I might replace the front section here because I'm not super happy with it, but this will be the only screen on this printer. And I think it's quite a cool addition. This one is printed on the machine. So you might have seen it on YouTube. I made a community post where I like had an IKEA bag over that machine as an enclosure. And yeah, this is what it pooped out. I still have retraction issues. Like the print quality overall is pretty good. It's quite clean. But I do have retraction issues. So you see it here a bit, it focuses. It's also quite dark. But yeah, it's not super clean here where it did retractions. So that's something I still have to figure out. But overall, like the quality is really nice. Like there's no ringing. And it's printing relatively fast now. So I'm super happy with that. Then, the last to-do item for today. Again, let's see how far we get. These are LEDs. I designed those bars myself, and they are supposed to go under the printer. So basically the goal is to have like illumination here around the base, more or less. And these are, my goal is to mount them on the bottom panel. I wrapped that in some cling film, just to protect it a bit. I regret peeling off the protective film last stream already. But the goal is to mount them exactly here. So we basically will have to drill 6 holes through that acrylic sheet. And then we like have, yeah, screws from the other side coming in. So I prepared heat inserts here. And the LED strip that's in here is just a demo or a dummy. That's something I just had playing around, but we will have a nice new strip going through here. And yeah, then the goal is basically just to have it like this. This kind of like works around all the internal components. And yeah, this should give a nice underglow to the machine, which hopefully looks pretty. Ironic, I won't be able to watch for much after school today. Oh, well, that's not too bad. You can rewatch later if you want to. But yeah, I decided to stream on Friday again. Because Steve has his Charlie Remembrance stream tomorrow at my usual time. And I kind of want to join that as well. So Friday it is again. Yeah, but these are basically the to-do items we have. Now I guess let's just start with the belts and the print bed lights. I'll just put this aside for now. Fold it. And then I guess let's peel it off. Let's actually just turn it off first. It would be a great step. Okay, let me think. I think we will get away with just leaving the belts in here. If we basically just remove the tension from the motors, we should be able to just pull them off. Let me just do that. So I'm just like loosening the tension mechanism on the motors. Yeah. So now this is like quite loose. We make sure that we kind of have everything in frame. And let me just pull this off. And I guess let's do the top one first. Doesn't matter. Yeah, so let's do the top first, but that means that we also have to work on the LED bars and make them shorter. Yeah, I pulled out the screw. That was not smart. That was a bearing stack. Well, let's not do that on the other side. That was not smart. I lost one bearing. We have to search for that later. Ah, here it is. Okay. Let me quickly check. I have 1, 2, 3, 4 shims. Yes, I do. And two bearings. No, then they're missing. Ah. Okay. That's a later problem. That was not smart. Okay, so, but we have the belts off. So then let's, actually we could have done it before, but let's tackle the issue of shortening those bars. So basically I have 2 of those connectors, and then I have, we can change this of course, but this is a cable I used before. And this also basically goes on one side. So what I would do now is I would just take this poor little guy and try to shorten it as much as possible. Potentially we can leave the part that goes out as it is, because really like we're missing like not a lot. So let's shorten the one that connects the two here, and then see if we are still too long. If yes, we also shorten this one. Potentially we can shorten this anyway, because I'm not sure if I want to use the white cable. And we can just maybe shorten that, and then we can desolder the cable here. Like this is just, you can see that. Oh, there we are. So this is just like soldered here. So if we cut this open, we can just desolder this cable and replace it. So let's start with this one. Let's see. So, I think the cleanest way to do that would be with a saw and like try to cut in here to the material. I wonder whether we can just remove the entire like transparent housing from here, because we don't really need it, right? The only thing we need is this connector here at the end, and this is connected to the PCB. So let's just do the destructive route. Potentially this just really shatters, or like kind of like shatters already. If I just let's see. No, it's more like a flexible plastic. Okay. Nevertheless, let me just grab another pliers and just peel this off. I'm just trying to not damage the cable on the side, so we can kind of reuse that. I kind of wish this would be like a more brittle plastic. Make this easier now. Not sure if that's a good way. Yeah, it's quite flexible. It's a shame. Then let's do the following. Let's get a saw. I use a small saw and just make a cut here. I don't technically also have a Dremel, but it would be a bit overkill. I guess if we make a cut lengthwise and like this side, we can just use the pliers to kind of like ply it over. Let me quickly grab that. Give me like 30 seconds. I'm right back. Okay, let's use this. This should be good. I actually also have a bit of a wooden plate as a surface. Yeah, that works. I just need to be careful not to. Not to cut too deep. I wonder whether we can also kind of break it a bit once it's weakened on top. See? I didn't expect those to put up such a fight. I'm not gonna lie. Okay, now we're through. Let's see. Here we go. Okay. Woo. Okay. One side. That's kind of what I wanted to have. So it's basically just PCB exposed to the end. So let's do the exact same thing on the other side. Ah, no, this also slides off. Okay. Let's keep this here maybe. Then let's do the same cut here on this side. But I'm not sure if we need it on this side to hold onto the strip. Yeah, for sure. So we can also cut here at the same spot, but we will need to keep the housing. So potentially we need to super glue that the PCB to the housing. Start by making our cut. I always wonder if that's stuff like I should do before the stream. Because like wiring the LEDs most likely is more fun than this. Is this deep enough? Yes. Let's repeat the same thing, that we just try to make a cut lengthwise. Also, a hot air gun would be like super beneficial here. Just to heat the plastic a bit. Make it a bit softer. Yeah, there we go. Yeah, exactly. And most likely we just need to have like a dab of super glue here later and just slide it into the spot where it needs to be. But then we need to keep this part of the housing we need to keep. Okay, well, then at least we shorten it. Let's hope that we don't have to do the other side. So, I'm also wondering whether we should replace this white wire. Like, I did damage it a little bit with the pliers. Like, it's not bad. But yeah, that should be still fine. Okay, so this is shortened. Then let's try if we are at the length we need. So I'm not gluing that yet, but like when we put it in, we should glue that. So this is one side, and then this is the other side. And then basically just goes in here like this. Yeah, I think we should like redo this because now the wire is way too long. So if we just have like two short jumper wires here, this should be better. But it's definitely like took off like quite a lot of like that. So here's the other side. But it most likely, now that I see it, like we most likely will have to like shorten both sides. Let's see. So just as a dummy, let's keep the unmodified ones here. Okay, so this is not a total setup. Let me see. So basically, these are the original parts, and we are replacing this part here basically. So this should go on here, just as before. Try to keep that stack intact, and this goes here. Yeah, let's try to mount it and see if it's within the right size range. It's not, I think. No, it's still too long. So we definitely need to shorten both sides. So here I'm like somewhere here. I'm like minimally next to where I need to be. Okay. I hope we are not like too long by a millimeter at the end. So then let's quickly do the following. I mean, this is the same housing that goes to the cable. So we also will need to do the same hack here. But I'm definitely like, if we take off this much, then we should be fine. So let's just take, I mean, I have two ends here. Let's just take one and repeat what we just did with the connector. And then I guess we just solder the jumper wires for this one, and then for here, let's find the nice cable that we use for that. I would need like a clamp here. I don't have like table clamp or something like that. Vice word. Let's see. I think that's already, yeah, good enough to just rip through. So let's try something else. Let's just go around. Nope. Ah. Okay, the back side you still have to rip rip apart. Like this piece we still need, right? We have to glue this here in place, that we can slide it on. And let's destroy this part. And this is not what I expected. Here we go. Almost off. Yeah, okay. This really puts up a fight now. Here we go. Okay. So then on this side, again, we have to glue that in a second. Let's put it in here. You kind of have to manage though, because like one is longer than the other, right? Because like one has those connectors on both sides. Let's see. I mean, you can always just add like a little bit of a dummy thing here at the end. Potentially just 3D print like a little extension here, just to make it like a couple millimeters longer. But for now, let's just try to make it work. Okay. So now the question is, this is as short as we get it, right? Because on both sides we now have the PCB. Let's hope that it now fits. Let's do this side first. Yes. Yes, this fits. Is it now even too short? Because I think they were kind of like on the outside. Yeah, I mean, now it's barely long enough. Let me try something. Let me try something. So we keep the short one on one side. We keep this one here as is. And we use the unmodified long one on this side. Let's get the modified one out. So this is now quite a bit longer. Ah. That still fits. Now I wonder what because now they're kind of like aligned on the outside, which I think that is where they need to go. And then basically we now have the light bars here. So the only thing is now, there we have this little loop of white cable, because we can't unfold this now here, right? But this wouldn't bother me too much, like we can tuck it away a bit and paint it black. And on this side, we will replace the cable anyways with something else, and then we'll just go to the back. I just have to manage it a bit here with the belts running down at the end. So potentially I thought about like moving it like this way around. Let's see. So, but then I guess this is fine, right? So this would work as is. Then let's just try to make this a bit prettier. And then I would say let's try to find a nice cable for that. I mean, potentially we can also just keep the white cable and just paint it black a bit. So, I mean, as for this cable on this side, the stick in the front, right, this is the one that kind of limits the length at the moment. So this one we can also just slide. This is still fine. And then maybe we can just try to make a little tiny loop here. Not pretty when you look at it, but this totally works. If we make it loop in a nicer way, that's not like Yeah, but this should work. Yeah, it's not that bad. So if we just keep it in like this, then this kind of like acts as a spring and pushes the second bar towards the end. So this is then more or less secure. I mean, those are a little bit wiggly, right? That's like kind of like intended, because they're just like sliding in here. But this totally works, and this is basically the perfect length that we need. Cool. Then let's just work on this side. Let's see what cable we have. I have the magic cable back. Length-wise, I'm not quite sure how much cable we need. I had a cassette. If I peek under the printer, our Wago terminals are on this side, so we need to go... I mean, technically we can flip that, right? Like, nobody forces us to have it come out on this side. So basically the Wago terminals are here on this side. So my idea would be then to just loop the cable around here and then have it inside the V-slot rail going down. And then basically where the cable chain on the back, like the cable chain here, goes under that, we also just add those wires. And then it should be basically quite a short run. So more or less what we need lengthwise. Let's just say we need 5 centimeters up here, and then we need 40 there and like another 10. So let's aim 60 centimeters. 60 centimeters of cable should be what we need. And twice, of course. Let's see, this is the cable we used for the entire wiring of the tool head. But this doesn't look like 60 or 120 in total. Let's see. I mean, this is definitely too short. This one might be just long enough. Let's see. Oh yeah, this is like 70 centimeters, like twice. So it's like 1.40 meters. So I would say let's use this exact cable. Yeah, perfect. This is also the 20 gauge, I think. It's a bit thicker. Yeah, 20 gauge. Oh no, wait, this is the 20 gauge. This one is then 24, I guess. Oh no, wait. This one says 20. Yeah, 20 gauge doesn't matter. Like it's a couple of LEDs. That shouldn't matter too much. So perfect. Then let's solder this side. Let me clean up a bit. Let's swap out the tip. We will need to do some heated inserts later though, so we will need this tip back. This looks like the wires go through. Let's see. So looking at this, it looks like the wires go in on one side and then go through to the other side. So most likely it's best to like heat it from the back, I guess. Maybe let's just grab it by the PCB. And then try to like pull the cable. Let me also put this aside for now. I mean, technically we can also just solder the wires on top and cut them, but let's try to get them out first. Yeah, that works. I pulled on the cable and it came out quite a bit. Yeah, here we go. Cable is out. Let's just quickly try to desolder that so that we can like also feed the new cable through. Grab a bit new. One side is free, the other one puts up a fight. Let me just add a little bit like proper amount of solder that like everything heats nicely. No, this side. This side doesn't want to. Let's try again. Let me just really add like a heap. Here we go. Not sure why that took so much convincing. Just clean it a bit. Cool. Then this looks now quite pretty. Like it's fully free, so we can also feed our wires through there in the exact same way. Let's just do the following. Let's solder it first, then we glue the plastic housing on it. The new wire is a bit thicker than the old one. Let's see if that just fits. Perfect. That's the one side first. Let me just clamp the PCB and the cable. Most likely have to file it down a bit to make it flush. This one doesn't want to go through. Uh-oh. First side was so nice. Why can't you? Yeah, well, that's the one that also had a bit of a problem in general. Let's try the following. Let's because there's still a little bit of solder around the hole. I put solder, and then maybe we just try to push in the cable from the other side. Let's just do it like that. Just have it upright. Yeah. Not pretty, but it goes through. Okay. It's through. So basically I just heated the solder that was like still in the hole a bit and pushed the cable from the other side. So now it's cable's through. Just have to properly solder it on the back. And we also need to make sure that we don't have a short between the two. And then I would just like file them down a bit to make them flat. Okay, so yeah, it's separated, but not the prettiest. Not the connection I ever made. That should be fun. Let's quickly. That's what we do. Yeah, there's a bridge. Oh no! Could have been so nice. Let's quickly see. Just from the pads. Yeah. Okay. That did not work. That looks tougher to me. Okay, let's just try to like remove a bit of solder and then do that again. Okay, let's see if we still have a short. And basically removed most of the solder. Am I retarded? That's a question I ask in most streams. Why is this a short? If you solder a cable that is connected on both sides. Well, that's the middle. Oh wonder, the short is gone if you cut the cable. Well, fun stuff. Let's add a little bit more solder then. Just to have a nice connection. Let's double check that we don't have a short. no short. Let's actually quickly measure from the pads. I don't like probing those solder joints because it's always a bit weird if you touch it properly. Yeah, no connection. Cool. Success. Where are you? Yeah, let's make this a little bit flush. Doesn't need to be too much. Just really don't want to have a short there. That would be not funny. Okay, cool. Then now it's just a tiny bit flat. And then I guess we can glue our end cap part thing. Yeah, that should be fine. Cool. Then that's the soldering for that section. Oh. And yeah, I'm still missing 2 bearings from the stack I dropped. So potentially I have to quickly like crawl over the floor and try to find my missing bearings. Let's not glue that yet, to be honest. Because if we just put it in, it still holds on, and then we still have the option to modify it if needs be. Because this is like fine. I don't think we need to glue it at all. This is perfectly fine. And then the other thing is what we could do, of course, because now it comes out from the front one. It does make a big difference, but we can basically just let's leave it like this. And then this just goes somewhere here and then to the back. And with the black cables, like this shouldn't be a big deal. And then this is how it looks from the front. Okay, then let me do my crawl of shame on the floor and find my lost bearings. I hope this shouldn't take too long. Give me like a minute. I'll be back. Okay, I have no clue where those 2 bearings went. I would say let's not get distracted by that. It's a bit weird. Because like they're not on the table here, I'm pretty certain of that. There's a lot of stuff on here though, so potentially I just don't see them. But they're definitely not on the floor. Let's see. Hi there, Fox. Greetings from Netherlands. Caught your link on the Steam server. Cool. Thanks for dropping in. We're installing lights today and lots of LEDs. Yeah, well, then I guess let's put it back on without the 2 bearings. And then at some point in the near future, I hopefully find my 2 lost bearings. Let's transfer the bearings that we have. Let's see if I can smartly. I mean, those stacks are not super complicated to build. That's the benefit of the Switchwire. Here we go. That's number 1. And then for number 2, I'll just install it now with the 2 missing bearings. Most important things, LEDs. Yes, we have tons of LEDs. There will also like, this will go underneath that we have like a nice glow around the front. Those are more utilitarian. They're not RGB. It's just like, I'm trying to recycle most parts. Like this is an Enderwire conversion, so it used to be Ender 3. Now it's a Switchwire, or like an Enderwire. And my goal was to like reuse most parts. So I still have the same hotend, which is not the Creality hotend, but like the MicroSiwss all metal hotend. But I still have the same hotend, the same BLTouch, the same motors, yeah, and the same lights that I used on the Ender before. So it's really like reusing as much as possible. Wait. Didn't we say we want to have the cables on this side? Because now we have them on that side. Let me peek. Yeah. The Wago terminals are on that side, so this is the wrong side. Yeah, seems very optimized screen. Yeah, I'm trying to keep the printer clean in a certain sense. Like I don't want to have like weird light sticks going out or something. Also for the camera, I'm at the moment still looking how I do the camera. Because if you look for like camera mounts for switch wires, like if you have a switch wire, you have the enclosure. I'm not gonna enclose this one. And then like you can kind of put the camera like up here somewhere, like here, like looking down. But that's not the option for me, of course. And then if you look in the Ender 3 kind of like section for camera mounts, they have like really like weird like arms coming out here or like arms going out there, and it looks like super clustered or like cluttered. So I'm looking, most likely I create my own one that like mounts the camera from behind on the x-axis, basically somewhere here, and then just looks down on the nozzle, just to keep it like nice and clean. Let's see if that works out. That's most likely for next week, given that we are doing or like managed to finish all the lighting stuff today. So perfect. Yeah, now it's on the right side. Like on the right, but also on the correct side. So let's see if I can throw this back on without dropping everything. This one doesn't want to catch. Let's see if we can finish one side. Okay, this one is on. Let's quickly see, the most likely the peanut moved a bit. It did. Okay, perfect. Minus 2 bearings, which we hopefully find in the duration of the stream. But yeah, this is now kind of how it mounts. This one, with those cables, we will need to clean up, of course. I hope it's long enough. Yeah, should be. Yeah, should be. And basically the not now, but like later, they will just go on top, basically like the belts here. I'm not gonna force this now over, but like the belts will be on top, and then like you just have the lights here in between. And then basically the tool head will cast a shadow in the middle, but that's basically where the tool head lights come in to illuminate that little like spot underneath. That could work. I've seen the side of an X-axis extrusion as well. Yeah, that's also like one thing I think about. Technically, you can like replace one of those like parts here and like mount it there. That would also work. That would totally work. But now, like on my V0, I also have the camera from behind, so I don't mind looking at the print from the back anymore that much. So yeah, I mean, back here, there also might be like a clicky at some point. Like for the Switchwire or the Enderwire, you need to have the servo arm, like handing the probe to the front. So maybe having it here is not the best spot. My main concern though is actually the cable, because like like those white camera flex cables, they're like super nasty to route. And if I mount it anywhere on the X-axis, like front back, I have to feed it through the cable chain. So what I actually ordered are like little like adapters that have the CSI connection on both ends, and then we will like create like a custom cable in between. I hope that works out. Cool. Then let's quickly replace those motor mounts. Let me also just like quickly. Yeah, no bearings somewhere in between. Too bad. Yep. Oh! Look what I found. There's one of the bearings. So now one more is missing. Let's see where we find it. Can I change later? If you're not enclosing the conductive probes, I love to use. Yeah, I mean, the thing is just like, technically I have a BLTouch here, which is actually quite neatly tucked away. Like, it's a bit old school, but yeah, here's the BLTouch. And this works pretty well. Like, I mean, it's most likely not quite as fast as the conductive probe, but it's not on top of my list to fix or replace. Cool. Oh, I remember we used those weird flathead screws here because it was the only screw type or like screw I had in the length. It's also something I wanted to replace and then like didn't do it yet. The BLTouch was just a real pain to wire because it's 5 volts and the tool head board I have doesn't consider the possibility of a 5-volt probe. So we had to do like all weird of hacks in the wiring basically. Yeah, look what I found, the second one. So now we are complete in the bearings. Amazing. Then I guess this is just like a really quick swap. So the only difference basically is that the new parts, it's the wrong side. So the new parts basically just have this little latch extra. So the problem was because on the Switchwire, the motor basically is just mounted on those two screws here. And then like this is a tensioning mechanism. This hooks into the V slot. You see a little hook here. And then you can tension it basically by tightening the screw. But the motor was allowed to wiggle like a little bit like this. So it wasn't super secure. And this part basically adds another mounting point here, which is like loose. It's just like to prevent the motor from having this like tilt basically in this axis. So I observed that for me being a problem. And somebody made this mod on printables. Not sure if I linked it already in the description, but I will. So I'm not the only one having that problem for sure. So this seems to be like a little bit of a construction issue. I'm actually sure if the normal Switchwire uses the same motor mounts or if they are like different. But nevertheless, let's quickly swap them out. Actually, almost certain that the front part still works. Most likely we really only have to swap this one part. Let's see. Should see what happens if I just put this on top. Yeah, exactly. It's exactly... Oh, no, it's different. It's also a bit beefier here on the bottom. That's the wrong side. Yeah, it's a bit different geometry. It's a bit different. Oh, it has an extra screw here. Ah, interesting. The original part doesn't have a screw hole here on the back. The original doesn't have it, and the new one has it. I'm actually not sure if I have extra screws in that length. And that also means we need a heated insert here, most likely. Yeah, on this side we need a heated insert. And then basically it screws in like this. Okay, then... Did I turn off the soldering iron? Yes, I turned off the soldering iron. Now let's quickly do heated inserts on the two parts. But it's just like generally like a more stable, beefed up part. That's great. So... I'm really excited for the LEDs on the bottom. I went through quite a bit of iterations for this LED channel, and I think I kind of over-engineered it a fair bit. So... let's see what our magic cable stack has to offer. Screw stack. So we have heated inserts. I have those screws for sure. Like, that will work. They're a tad longer. Yeah, they're a bit too long, but we can shorten them. So we can use them. We can use them. Let's see. So this is the cable set. Okay. What do I have now with cable? The hardware kit I got. Oh yeah, perfect. So we have 3 more, and we will need 2 extras. Oh! We have even more randomly flying around in here. Hi there, Bertja. I don't think you'll need those those holes are for the screw heads. Yes. So in the original parts, I have 2 sets of parts here. Where's the original one? Somewhere it's the original one. Here. This is... Oh, this one's the original one. Here. Those are the exact same parts. These are a mod, and they have like a mounting hole up here to prevent the motor from tilting forward. So this is really just like to keep it vertical. And I observed, and seemingly somebody made the mod having the same issue. The motor's tilting a little bit forward sometimes. So they have this extra hole here, and then on the, you see here the original part doesn't have a screw hole, but this one has an additional hole. And here we actually will have to have a heated insert, and just clamps it together on the bottom as well. So just a bit beefed up compared to the original motor mounts. But yeah, you're right, the original ones do not need heated inserts. Let me just make sure that I put the heated insert on the right side. Yeah. So these two parts get 2 heated inserts on the bottom, and then on the top it's just for the screw heads. So let's quickly put it in. And my thinking was, if I already have to pull off the belts for the LEDs on top, let's just do that right away. So then this goes on here. This we copy directly over, like this little hook. And then this goes on top. I see, I thought you were gonna put 4 in the top. No, no, no. Only the one on the bottom. I'm an expert in putting heated inserts in places where they don't belong, but this time I'm very, very confident that I'm correct. No, this hole didn't print super well. Oh, let's see it. Okay, perfect. And this is assembled again. Oh, I also remember we had the issue here that the T-nuts were too wide, basically, and we had to use those 3D printed little T-nuts here. 1 second, let me quickly clean out the dust and dirt there. It's incredible how quickly a printer gets dirty. So, let's try to... I remember this was quite a pain. Let's see if I get this back on. This one seems fine, no? I think you've got a different sturdy version than I used. Yeah, exactly. Oh, no, wait, a different sturdy version. Mine just screwed into the plastic on the bottom hole. Oh, so you mean instead of the heated insert here, they just screwed into plastic? Ah, interesting. I mean, most likely it doesn't really matter. See, I even forgot adding... I even forgot that screw. Let me quickly... But then, Bertie, did you also have the problem that the motor tilted like this a little bit? Because that's the only reason I replaced those, that I have this like little extra thing on top. That's the only reason. See that we get this. Yeah, completely off. Let's see. I'm actually considering whether we should replace those. Let me quickly check, because I think we still had quite a number of those. Let's see. So I think these are M5. Yeah. Because one we can definitely have as a normal one, quote unquote. Where's my tweezers? I'm losing everything today. As always. So the whole problem was that, like, on this side there was not enough space, if I recall it correctly. Oh yeah, because of the hook. I remember now. The hook was the problem. The hook. So basically there's not enough space here. Peeling little tiny bits of filament out of the deck of my V2.4 is never fun. Yeah. It's also like, I kind of want to keep it clean, but then it's also like a tool, so I'm not really bothered too much. But I think a bit of like cleanliness is good. Okay, then let's try to maybe have a combination that we have one of the proper ones and then the plastic one here. Let's just try to get the plastic one in first. Yeah, that's in now, I think. Okay, perfect. Let's do this somewhat tightened here. Okay, and now basically the big upgrade. Sure to. The big upgrade now basically is this one here. So here we now can basically, let me just put it. So here we can now add an extra screw. And just make sure that we not have one that's sliding down freely. And then we need the M5x10. This is really just loose, I think. I'm not sure if we should add a little bit of like, let's actually do that. Let's add a tiny dab of thread locker there. Somewhere here. Just a tiny dab. And we don't have to tighten that at all, basically. It's just really to like prevent it from tilting. a tiny little bit of thread locker. Perfect. And now this can, if it tightens it a bit too much. Yeah, so this can now basically move up and down, which it should, but it can't tilt anymore. So the top screw just prevents this tilting motion. Tiny bit more. Yeah, perfect. Cool. We could have added the belt before, but why make it easy when you can make it hard, right? See if we can get that filled in. Yeah, it is in. Cool, perfect. Let's quickly do the other side as well. I always forget to turn off the soldering iron. I'm still building my Ender 3 to Switchwire conversion, almost finished though. I just need to finish the canvas wiring from the toolhead. Went with the sturdy mounts from the start of the build. Yeah, that's smart. I always try to like build it, like always. Like I for the two Vorons I built now, I just try to build them as is, or like as it's like intended, and then add all the mods and changes later. Not sure if that's smart or not, but I like to have like the vanilla version first. But yeah, this one is definitely like, I mean, you even see it now. Like if you look from the side, like you see how the motor just tilts. I think it's partly just because the motor like has like, it's heavy on this side, so it just like naturally wants to tilt a bit forward. And I'm not sure the extension of the belt just isn't enough to really pull it up like properly. So yeah, let's just quickly do that on this side as well. And then we can add the missing two bearings on top, and then we can already restore the belts. And then I guess we can quickly do the wiring of the LED, which should not be too complicated. Oh yeah, we should not forget to plug in the motors. That's something I will forget. And also quickly, those two are the old parts, so we can just already toss them out. But yeah, Bertie, your way is definitely more efficient with filament. Because like those parts that are not printed, they're really just kind of like pointless. I mean, they did their duty for like a short little while, but not for really long. So. Wait. You just screw up. This doesn't have holes for the screw heads. I'm confused. It has holes on this side, but it's the wrong side. No, it's the right side. I'm just retarded. God. Sometimes I'm like not super quick. Now we've got the hook. That's indeed a lot of wiggle space. Even when the belts and screws are tensioned, did it cause any artifacts when printing? I am not certain if that caused artifacts. I think what it can cause is inconsistencies in the Z offset. That would be my thing, because like basically you're changing the... I'm not quite sure if it's like bad enough that you really notice it, but technically, like, because it changes the belt tension, right? Like if you, let's say like you twist this motor forward, this will change the belt tension ever so slightly on this one side, because like you prolong the belt run a little bit. So technically it should cause the X-axis to like do that, right? But I'm not sure if this like little like wiggle here is enough to really have a big impact on that front. I'm sure I didn't notice anything. It's just like my fear was primarily that it would cause the belt to rub on one side. So that was like the reason why I wanted to fix this. It's like primarily just to have like the belt run properly over the pulley. Yeah, those are like much nicer parts. That's definitely a good upgrade. Oh, I didn't pay attention to the motor orientation. We need to have the plug of the motor on the other side. This way. The other side is correct. So, here we go. Okay, let's do the same thing here. Sorry for all the black parts. So let's kick out one of those. Just moved it over. This one comes out easily. So this one goes on this side. And then let's use one of the proper metal ones on the other side. Okay, let's try to get this one in. Okay, that's a success. But yeah, it's like naturally just like, because the motor is on one side, it just tries to like, of course, fall over. We again made the smart decision to forget the motor. Quickly fix that. And, let's add our M5x10. Perfect. Yeah, those look a lot better than the normal ones, and should indeed help a lot, causing the belts to rub. Yeah, that's exactly what I think as well. But if you're building also Enderwire, did you do the self-sourced route, or did you go with the new kit? I think from Seaboard that is available. Because I basically bought all my parts before the kit was available. And it caused a little bit of headache on my side. Because basically I got a fastener kit, but that was meant for the revision 1 of the Enderwire conversion. And I'm kind of building a revision 2. And it was a bit annoying because like the parts I had did not 100% fit what I need, as evident by those screws, for example, that I just had to like get from my stash. It's a bit too tight. Yeah. Okay. That works. Good. Now my little tiny screwdriver wants to run away. I think the one on the back we can tighten a bit more. I just need to be careful here because it's the one that screws into plastic. Yeah, that's fine. Like the thing is now that we have this one, I'm not super concerned about the screws on the bottom, to be honest. Okay. Then this one we need to fix up. So let's quickly sure if we have to pull it off anyways again to route the belt around. So let's just quickly get this off. Be a bit careful with the cables. Okay, then let's do our bearing stack here. Okay. Shim, washer, shim, bearing, and shim. All back in order. Okay, so this will be a little bit funny now. I'm sure maybe it's smarter to just loosen the belts in the middle. But I kind of like counted teeth-wise, so I tried to not loosen them. So we kind of have to get the belts. Let me quickly give this like one twist. So technically we can like pull this down on, wait, we can't rotate that. So let's quickly sort this out. So this one goes here. And this one goes here. So I guess we can tighten this one already, and then we just need to deal on the other side with the belt tension. I looked at some kits, but I already had the linear rails, wires, bolts, so self-sourced was the rest. Okay, yeah, okay. Well, if you have the linear rails already, I think it's kind of like the most important part. Or like the most expensive part. Then yeah, I guess self-sourcing makes the most sense. But then you also don't enclose it, or did you get the enclosures? Because I bought the deck panels and the bottom panel laser cut from a company here. And like those 3 panels was already like 70 euros. So I'm not gonna enclose it, but it's also fine because it will end up in like not a closet, but like a enclosed shelf. But I'm not really aiming to print a lot of ABS with this one. So I'm also not really concerned about the enclosure. Okay, let's see if we can get this all sorted here. Oh, wait. Do we have them now over cross? Yes. Let's quickly try to get one bolt in. Okay, perfect. Both bolts are in. Oh. But on the bottom, the belt is not where it's supposed to be. Let's quickly check that the rest is kind of in place. So yeah, it's only this one problem. So basically here it slipped over the pulley. It's not on the pulley. So we have to quickly loosen that again, I guess. Just have to pay attention to the LED bars in the middle, that we don't break the LED bars with the tension of the belts. Okay, now that's in place. Perfect. Cool, then that's kind of up. Let's just make sure that everything is correctly positioned. I'm not sure if that's the best way to do it, because I'm tensioning the belt already quite a bit with like just positioning that here, but that seems to be now okay. So this is kind of like on the outside aligned. This one can actually go a little bit in, just a tiny bit. Just here. Okay, perfect. Yeah, and those are the perfect length now, and you don't see the white cable that is kind of tucked in here. Maybe I could have even added the cover here. I mean, it's something we can still add, right? Like we can just clip it over the LEDs, like it just like wraps around. Maybe with a small reflector. That would be really cool. But it's something we can just like put on top, literally. You know what? You don't see the LEDs actually, and then like just have a reflector in 45-degree angle or something, just like keeping the light there. That would be pretty cool. Hi there, Eduardo. What gauge and type of wire do you use for all hotend wiring? For the hotend, I use two different type of wires. So I don't have a CAN bus board. I have the normal toolhead board. And I used 20 gauge. Wait, this is the cable I used for the toolhead wiring as well. This one is 20 gauge. So I used 20 gauge for all the wires except for the hot end. For the hot end, I used this one here, which is 18 gauge. So the hot end, like the ground and the positive lead of the hot end, was 18 gauge, and all the rest of the toolhead wires are 20 gauge. You find actually the link in the description to all the parts and things I bought. So the cables are also linked there. I went for the full enclosure route. Also saves dusting off the printer once in a while. I think it cost me something around 140 euros for all the panels. Oh, okay. Yeah, 140 is not too bad, to be honest, but still, like, it would be like half of the entire part cost for me. But 140 is not horrible. I guess you also know this at a company. Like, the things for me, they charged like a base project fee basically, which was like 40 euros already. So just like the to get started fee was 40 euros. And then like each of those top panels was like 6, and I think the bottom panel was like 7 or something. and then like shipping, and then it added up to like 60 something euros. But yeah, I mean, I can still add the enclosure later. I just have to pay the project fee again. Cool. Okay, so this is okay. We just have to tension the belts again because they are definitely at way different tension levels right now. Let's actually do that. Oh shit. Okay, yeah, we quickly have to undo the bottom tubing. Okay, so basically what I always do, oh no, oops, we can't move up anymore, which was not a problem for me because the shelf this goes in is like 5 millimeters higher, so I kind of like configured it already that this is the max height, but right now I cannot use the top anymore to like make sure we are level. That's a shame. Let me think, how can we solve that? How can we solve that? How can we solve that? Because like basically what I want to see is that like both sides are perfect level, basically. So this is not a perfect mod. Well, I have an engineering square, so we can maybe use that. Let's maybe use this. Oh. So basically, instead of like making sure on top, we can also make sure on bottom that this is the same height. So ideally, I would have two, but you see here, this doesn't fit anymore. But then the problem is we're also then kind of working with the level of the bed, and I know that my bed is not level. So potentially it's best to use it against the top. Oh. And we can do it here. Kind of like this. That's also not quite ideal. But yeah, I see it's definitely way off. Let me think how to do that. How to do that? Is your bed static? Yeah, more or less, but it's definitely not level. Technically, I could still use it to level the gantry, but I'm not sure if I want to do that though. I would rather prefer having it like square to the frame. For my MicroSiwss Plus, I printed 2 columns that could be used to square the gantry before prints. Yeah, that's actually like the only thing I really have with the defined height right now is this. And I only have one of those, which is a bit of a shame. Okay, so how about we like kind of like do it roughly now, and then I think I go with ballistic tax approach, and we'll just print like 2 columns I can use to level that, either to the frame or to the bed. But then let's just go ahead and do it on the bottom. Well, what we can also do is like first we can make sure the tension is the same. Then it should be already quite close. Do I have a phone here? I don't have a phone. Let me quickly grab a phone. Then we can use the Prusa belt tension thingy to make sure that both belts have the same tension. Okay, let me quickly grab a phone. I'm right back. Okay, I have a phone. Let's just select any random Prusa machine. So, I'm not quite sure why this is German, but so basically my goal is just like to have left and right the same hertz. Okay, let's aim for 134. Let's see what we have on the other side. Less. So let's tension this side. Let's see. Okay, still needs some more tension. This does not work very well. Not sure why it now says much less than before. No, I also just noticed that on this side there's no tension at all. Like it's just on the bottom of the tensioning mechanism, so let's just pre-tension it a bit. Oh, it's just some. No, it goes way higher. Okay, so it's like 137, 138. So this side needs way more tension, which is weird. Let me just check, is this all like kind of like aligning properly and we don't have any... Aha, here we have something weird. There, it's not properly on the roller. Here we go, now it's on the roller. Same here, not on the roller. Okay. Let me also quickly unplug the motors. Because by moving the tool head manually, I killed the stepper driver, or like 2 of the stepper drivers. Let's just leave them unplugged while we move around the stuff here. Okay. Let's see. Let me just try to like show both sides. Let me just move this up again and then let's just see. Oh. Ah, see, now this is like completely loose again. This side is okay-ish, but this one is completely loose. So let's just... make sure to tension that. Yeah, this doesn't really... like the tension, it just jumps around like crazy. Yeah. Let me quickly check if I have a different... Oh yeah, I also have this app. Let's see. Test. This doesn't do anything? Okay, cool. I'm not sure if this font is a problem. No, this doesn't do anything. Let me see. We have to... Oh! Ah! I have to kill Chrome, otherwise it doesn't work. No, it doesn't do anything. Okay, this does not work. I use a small torque wrench instead of when using the method. Seem more consistent. I mean, I can try this. Just like this doesn't react at all. And the Prusa thingy. And the Prusa thingy is just all over the place. I mean, this says now 120-ish. And here it jumps now between 60 and 90. So this seems to be quite a bit lower still. Let's try to lower this side of it. Oh, let me try this again. Still 120. Just making sure there's still like a little bit of tension. That doesn't make sense. Like I reduced the tension and now it's saying like 130 Hertz instead of 120. Yeah, the right side is way too loose still. It jumps like from 119 to 150, like there's not really like... Okay, let's assume it's 120. And yeah, this needs definitely just visually way more tension. Yeah, it jumps between 60, 90, 100 something. Like this doesn't like what is this? Okay, this just doesn't work. Like if I'm having like 50 plus hertz like difference between the plugs, then that doesn't work. Let's just do it by feel. And then I'm thinking about something smart to figure it out. Maybe let's use... Let's just try to use this one here. If I just like put it in between the top of the block and the stopper here, and we have an idea where we are. Yeah, and this side is still like way tighter. So basically, if the two sides have the same tension, the gantry will be squared. So this one will be the same on both. And this one is still way more. The problem is, and that's what I don't understand right now, we're almost at the, like on this side, we're almost at the end of the motion range from the tensioning system. And here we are like not even super tight. So I'm a bit confused why we have suddenly this massive difference between the two. Because before we took it apart, like, I don't think it was such a big difference. So I wonder whether there's some issue that we have the belts not properly aligned somewhere. But this looks all good, like it moves fine. So let's tighten this here more. And let's loosen this side a bit. I never got the Prusa one to work for me. Well, I used the Prusa before, it was fine. But like also the other app now on this phone, like the other app doesn't work at all. Like it doesn't do anything. So maybe there's something wrong with the phone. Let's see. So if we have this here, yeah, now we are still tight here. So something is not right. Oh no. Now we are higher here, so this side needs more tension. And this one is not too tight. Let's see, so like, I wonder why this is such a hassle right now. Something is not lining up here. I'm not quite sure what. Because it's quite a, like, there's quite a difference between the two belts in tension. And I'm not sure why that suddenly would be the case. Like, it all looks fine. I also tried to do it at the same hyperbole in the middle of the belt. Yeah, that's true. If you have it in different heights, it also will influence it. I'm just trying to understand like why I have such like massive differences in the tension. So if I increase tension on this side, I mean you see it, right? So if I increase the tension here by pulling it out, you see how it wiggles up here. At the moment, yeah, we need more tension on this side. But this one is also, like, this feels tighter than this side, so I'm a bit confused. So I kind of need to tighten this one here just to have the belt kind of tensioned. And I also need to tighten this one quite a bit. I'm not sure if something I'm doing wrong right now. And now it's kind of, with my very precise measurement unit, now it's somewhat equal. Yeah, still needs a bit more. But now they're both like really tight actually. So let's try to lower the tension on this side a bit. Highly scientific what I'm doing here. So I definitely have to do that again later. Okay, it seems to be now somewhat on the same height with my very precise Allen wrench measurement unit. It's a tiny bit more here. Okay. Yeah, now it's fine. Tiny bit more. Okay, let's call this a day. I still feel like this one is way tighter than this one. But it moves fine, so that's good enough. Yeah, and then I think I go with what Ballistic Tech said. That's actually not square to the frame, that's just square to the bed. Meaning I will print 2 cylinders, not on this printer because that's like compromised, but on my V0. Just to like have like equal height from the bed. Yeah, I think that's fine. Okay, cool. I did not want to spend so much time on squaring that. Perfect. Then let's quickly plug in the motors again before we forget that. And let's take care of that cable. So we're already like 2 hours in for just this one part, and I'm actually way more interested in doing the LEDs on the bottom. Okay, so let's see how we route them. So my idea was to just route them, I mean, either around the side, or what we can also do is we can route them on the inside, right? Like here, but then they're like a little bit more visible maybe from the front. That's what you see. So we can route them here. To be honest, it's not too bad. Like, I mean, you kind of see the cables here, but it's black cables, so I would be fine with just having them here. Let's go with this direction. And the other way is also shorter, so if we ever want to change that, we have enough cable length. Okay, so they come in here. And then I guess we can just push them into this V slot. I had printed V slot covers, but I don't think I have any left. You see them here. Like, it's all black. Here, like those V slot covers. So I had some, but I don't have any left, I think. So my idea would be to just add like another V-slot cover over here to just cover those cables. And then here, basically just to like put them over into this one that goes down here. So I will just leave them bare on top for now. And let's just quickly remove those here. So they kind of like go somewhere here, and then under the motor, basically, we can just pop them over into this other V-slot profile here. Let's try to cover that again. Make sure we have enough cable there. Yep. This doesn't want to go on. Here we go. Might need to shorten that tiny bit. That will be perfect with the top slot cover. Yeah, I think it will look really nice. Just a bit annoying getting that there. So here we go. Make sure we have enough cable here. Oh, actually, like we can keep this in the same slot already. Because the motor, there's space here, so we can just have this here. So this is how much cable we have on the bottom. Let's just feed that to the bottom. And then let's figure out where we plug this in. So here are our cables. Oh no, the bottom one popped off again. But right now I realized that I made a mistake. For some reason in my mind I wanted to plug them into the Wago terminals, but that makes no sense. They need to go over here. So I have two mainboards for everyone who's new. Because I have two extruders basically. So this mainboard just drives the y-axis and this one drives everything else, including two extruders. But my idea was to use the bed or the hot end MOSFET here basically to control the lights. So instead of turning on and off the bed, it can turn on and off the lights. But now the problem is that we are on the wrong side. I mean, we can make it work. The better way would be to pull it off again and move to the other side. But that's not really, like, I kind of want to finish up with this part, to be honest. And if I pull this off, let's quickly check if we can turn the light bar around without removing the belt. If we can do that, then let's do it on the other side. Okay, so one. We can pull out. Okay, so one we can pull out. But the other one is completely in there. Okay, let's not worry about the belt tension. I ignore belt tension. I will take care of the belts tomorrow. That is like a tomorrow problem. Then I print the tower. And then we do that this way. So let me just quickly pull this off. And then we just flip that light bar around. It also means we have to pull off, or like we can just pull it through. Okay. So this goes this direction. Then let's also have the bar with the cable on the back, basically. So this goes here. And then, well, here. Let's plug this in here. I expected this to be easier. Not gonna lie. Here we go. Okay, let's quickly do it with the belts. Okay, make sure this is properly positioned. Okay, success, we flipped the direction. Okay, let's do it again. So, let me quickly put the slot cover back. There's one slot cover somewhere. There it is. Okay, then let's peel off those slot covers here. And feed this cable through. Oh wait, but we want to have them on the inside, right? Let's do that. And then put this back. There we go. Just need to make sure that we like account for enough cable here. Okay. And just push them under deck already. Perfect. Top one is still a bit weird. Oh. Like those printed cable covers are not super sturdy. Don't look at it too harshly. And let's just make sure to have a bit cable here. Let me actually just that we don't accidentally pull too much cable under deck. Just add a little tiny bit of tape there. Just to remind us. Okay. Then let's try again. Yeah, now we have them on the right side. Carefully pull in the cable we are allowed to have. There's a loop in the cable. Here we go. Okay. So, I mean, really all we need to do here, that's a bit of a messy spot. Try to get them in next to each other. Here we go. So all we need to do basically is put them here. The only thing that I didn't pay attention to now, one of the two cables is ground and one is 24 volts. And I'm not certain which one is which. I mean, worst case, they don't light up, right? Because it's LEDs. I don't think anything bad will happen if I mess up the polarity for LEDs. Let's see, let's just quickly get them under here. I will also leave those cables long for now. Just so we have a little bit of like wiggle room on top. But then basically my idea would be to just use the hot end here. Let's just quickly check that we make sure we know which one is positive and which one is negative. And then I'm also considering crimping on quickly a ferro connector. see if I have the correct ferrule here. I do. So let's put that in. Yeah, this one is good. Let's quickly crimp on the second one. Let's actually quickly wait. And then basically one of the two cables I will mark with a positive. Like with the red little wrap. I am muted. Sorry. I'm not sure how long I was muted and why I was muted. There's no continuity here. So I'm not quite sure why that would be. Let's try the other side to see if it's like a issue in this bar. So I hope I wasn't muted for too long. I have no clue why I was muted. So let's see here. No, I don't have any continuity there either. Ugh. All the time we spent on that belt tension. All for nothing. Let's see. Maybe there's an issue here with this. Okay, now it falls apart. Let's check continuity right in the beginning. Yeah, here I do have continuity. So it's not my botched solder job, at least not on this side. Yeah, this is perfect. But then let's quickly figure out which one is ground, that we have this one solved. So where did now the connector go? Ah, here. So this one is the same, and here ground is on the left side. Left side is ground. So I'm just making triple sure because I'm always screwing up with stuff like that. So left side is ground. Let's see which one is ground. Okay, so the one we crimped already, that's the 24. Let's do the following. I have like a little colored heat shrink. Okay, there's it wants to come out. Let's just take a little tiny bit of that red heat shrink and put it over the 24 volt. Just to double check again, the one that is crimped is going to the right one here. Yeah, and the right one is 24 volt. Okay, now I have to quickly remove that again. Just quickly put this on here. Now we have a nice little marker. Diode in the LD bar. Oh, there could be a good one. Maybe there's a diode in the LD bar. Let's quickly check the continuity over the LD bar itself. But then we now at least know which one is ground. That was the important part. Let me just check if I get continuity. Yeah, I heard it beep briefly. Yeah, I do get continuity over that. So that should be fine. Let's just build it up step by step and see at which point we lose the continuity. But good we checked now and didn't waste too much time on the belt tension. Okay, so this one. Let me just grab the 24 volts or like the ground on the back. And see if we have continuity. Yeah, here we have continuity. So this part is fine. Then let's see if we add this one, if we have continuity. Oh, let me grab that in the back, and then here, getting a bit difficult, but I hear it beep. Yeah, this is also continuity. Let's add the strip. Yeah, it's also continuity. So that should be all fine. Let's put it back together. Yay. So this goes here. Let's mount this side. This is really not that easy to manage LED bars and cables and wires, and let's leave the bar out for now. Just needs to be behind belts. Okay. Let's get this one up and running. Then we can put in this end. And we can put in this side. Put it over here. Let's make sure we have the bells over that. And then we can try to try to mount that. Perfect. Okay, now I can't check continuity anymore because I can't access it. But should be fine. I'm quite confident. Minus that we put the belts over cross. Here we go. Okay, and belt tension, this is like not tensioned at all. But this is something then for another day to check. And now it's not tensioned at all. Like there's like no tension whatsoever right now. Something can't be right there, because like there's so much like lack of tension that even if I tension now the motors to full extent, I don't think I get enough. Okay, let's really ignore the tension for now. This is not what I want to focus on right now. I mean, there's enough wiggle room to do tension, of course, but let's put a bit of tension on there. No, seriously, like, what did it do now? Huh. There's some mystery going on again with the belt tension, but again, let's not waste time on that. I'm just kind of tensioning it, that's not falling off, but it is not not acceptable. Let's flip it over. And let's make those cables pretty. So I will really just leave them a tiny bit long now, until I have the final like setup on the other side. Let's see. So basically we just make sure they're kind of the same length. And then I would just remove a fair bit of the isolation. And then let's just put the ferrule connectors on it. Okay, now knowing which one is the positive and which one's the negative lead. Let me quickly grab my small screwdriver. And I will definitely shorten those cables, but for now it's fine. I'll just tuck them like under the main board. Okay, so technically, if my electronics knowledge is not completely off, this should be it to drive the LEDs. And this took us only 2 hours and 40 minutes to get to this point. That was not what I was expecting. But this is how it is sometimes. Let's see. Let's quickly do like another just a sanity check that we don't have any shorts. And then I would say just let's turn it on and make the LEDs fine. So I'm just checking that I'm not having any shorts anywhere, which seems fine. So let's if any magic smoke comes, it's from this area. Let's see. Looks fine. Nothing exploded. And let's flip it over. Oh, now I see what the issue is. This belt is not on the... We had it on the other side before. This belt is not on the pulley. That's why the belt tension is horrible. Okay, again, like, let's not worry about that right now. Let's see if our LEDs can go blink. Okay, so let's quickly jump to the browser. and hope that the browser works well. Amazing. So let's see. We plugged it in the SKR Mini E3 V1.2 pinout. And here, so I connected now to the the E0, which is the PC8. Yeah, so this is high side switched, which is perfect. So basically what we do is let's just put it where the other LEDs are here, the NeoPixel ones. So we just say output pin. Pin is, what do we now say? PC8. V1, which is the second MCU, PC8. So on top, basically, I configured 2 MCUs, heck, 3, but one is counted out. So this one is the SKR Mini E3 V3. It's the main one, and then this one is the V2, which we had temporarily in there, and this one is the V1. So it's all SKR Mini E3, just like V3, 2, 1. I have one of each. So we are using now the V1. And I think we can say PWM true. Let's quickly check the Clipper config for output pin. Yeah, exactly. We define a pin and then we say PWM true, so we can hopefully control the brightness. Shutdown is 0. Yeah, that should be it. Oh wait, we didn't name it, right? Output pin, bad light. Save. Okay, let's see. Yeah, we have now bad lights here as a slider. So let's see what happens if I set it to something. Well, I would say the PWM thingy doesn't work. We need to set a frequency most likely. But it works. They turn on. So that's good. Let's see if we can set a PWM frequency, because that needs to be way up. Cycle time. It's recommended this be 10 milliseconds or greater when using software-based PWM. The default is 0.1. Well, 10 milliseconds is not really something we can do. That's not fast enough. Yeah, Bertie, let's go. Enable this to use hardware PWM instead of software PWM. When using hardware PWM, the actual cycle time is constrained by the implementation and may be significantly different than the requested cycle time. Okay, then let's just go for hardware PWM true. Not really like anything we can do besides that, so let's also do that. And then the cycle time. Wait, I did now jump. Here. And then the cycle time. So it's in seconds. So let's go with 1 millisecond first. Let's see what that does. That works. I mean, you can kind of see it here on the tool head, right? Like how bright it is. So this is definitely controllable now. I would try to like pull the frequency a bit higher. Like I don't see it flicker actively, but let's just go 1 order of magnitude higher. Not sure if this is not full brightness though. But 100 should be fine, right? So it doesn't cycle. Because I know with fans, if you have too high of a cycle, they don't have the full power at some point. But for lights or LEDs, I don't think it matters. Yeah, that's fun. That's perfect. Now basically, if we move that down, and the tool head, so during printing, like we now have like the illumination here from the tool head LEDs, and then around that, like this is like, not sure if you can see it on camera, but this is definitely illuminated from those lights. Right, if I put this off, yeah, you see like it's definitely like bright. So that's nice. You have this shadow here, which is a bit annoying, but like the tool head LEDs like light up this area, which is an important part. So this is perfect. I really like it. Especially if you can dim it a bit. Not sure if I will use it. Potentially I just like remove the slider and just have it as a one like on-off kind of thing. Perfect. Let's add that also to the macro that I have. Because I have a macro for here, light pending, light printing, light off. So let's just set output pin. Oh, I think it's just set output. Pin equals bad lights. And value is 0. And then light printing, we set this to 1. And light pending, let's just set it to 0.4. Just making something up. Yeah, let's see if that works. Oh, it's set pin. But I have something else, right? I have set output. Set pin. Set pin. Set pin. Okay, so now we have light pending, which is the red thingy here, and like slight illumination up here. And then we have light printing, which is way brighter. And then we have light off. Perfect. Let's actually pull this down. Oh, did I? Not sure if I now showed the editor while I was editing, or whether I showed the desk. But let's just put this to 0.2. Just a bit darker. Perfect. Then this is done. Again, like let's ignore the belt tension. I have no patience right now to figure out the belt tension. But what I do have patience for is installing the LEDs on the bottom, because this is what I really wanted to do. Let's just try to move this to the side as much as possible. Bit of space. Not too much, but a bit. So, this is our bottom panel, wrapped in cling foil. The idea is to have these LED channels on the bottom here like this, mounted to the panel, that they also come off with the panel. Yeah, that's basically it. And then my goal is basically to have like an underglow in the front area. So they basically more or less aligning like this, right? So that we have like an underglow in this area here. That would be my goal, just for coolness. Not really anything practical, of course, but yeah. So how they work is they have this like clipped on lid basically, and they have a white reflector inside, which I printed. Like the black is ABS and this one is PETG. So they have the reflector, and then basically on this side you can see the LED strip I put in. Like this one is the old one I used before. It doesn't like hold down anymore properly. But we'll use a new one in a second. Also, this one has 60 LEDs per meter, and that's a bit too much for that. So we'll use a lower density one. Yeah, so basically that's what I designed here. I had some iterations. So I also had an idea of having these like mounting thingies that you tape, glue the LEDs to that and then insert that here, but that, yeah, didn't quite work out as I wanted. So we'll just glue it directly. Oh yeah, and these are, the parts are printed on this machine. And I think that turned out pretty well. Like again, it's black because black is amazing for streaming. But yeah, it's really nice quality. Like there's no complaints. Like it's really stacking nicely. Yeah, and on the bottom it's transparent PETG. So this is just like to diffuse the light a bit. I went like all out on like diffusion, that you can't see the individual LEDs, but I think I went like all over the top. So let's do the following. Let's make sure those are mounted to the bottom panel first. I think that's a good first step, but I'm low-key scared of screwing that up. Let me quickly take a sip of water just to mentally prepare. So, what I did is I created this little jig, which perfectly aligns with this Enderwire bottom panel. And technically, I mean, this doesn't like move. It's like locked on this side and this side. And if we drill those 3 holes, we should have the perfect holes for mounting this. But I quickly want to do like a sanity check. Let's actually start with inserting like 3 heated inserts on each of them. And then let's do a quick sanity check that the jig is properly lined with the holes. And then let's drill the holes. See, the cable of my soldering iron is kind of like a little bit in the way. See? Seemingly needs a second to heat up. Here we go. I did not add a lot of clearance. Like the bottom of those holes is not really like I think the depth of the hole is 5 millimeters and the total thing is 6.5 or something quite high. Need to be a little bit careful to not push them too deep. They pushed really hard. Let me just heat it up a bit more. And my external monitor just died, which is also good. You organized it here on my laptop. Okay, so this side is fine. Let's do the other side. Really curious if this will look the way I imagine it to look. And things like the channels, we can iterate over the channels. Like I can make a new version for next week. The only thing that's kind of fixed then is the mounting holes. It's like the only part of that I'm not supposed to screw up is the mounting holes. So I'll be very careful there. Okay, let's do a quick check. So this will go this way. So we have 1 hole, 2 hole, 3 holes. So this obviously works perfectly, as if somebody designed it in Fusion. Cool, perfect. Just a sanity check that like I didn't change like the whole pattern accidentally between like exporting this from Fusion to that from Fusion. So then basically my idea is to use this drill block. It doesn't droop so much in the back. And basically drilling one side, then we have to flip it and drill the other side. Right, this makes total sense. So this one now works like this. And the other one, I basically take the jig and I rotate it. And then it works like this. Yeah. There's no flaw in my logic. Yes. Cool. Then I guess all or nothing, right? Let's drill some holes. This was a hole. There's a hole. See, you can look through. Okay, 2 more to go. And then I would say like we test fit one side before we drill the other side. Second hole. third hole. We have 3 new holes. It's still wrapped in cling film, which I will leave for now. Now basically this should be mountable from the outside. What we need to do is we need to chamfer the countersink the holes. Just to check. Let's use some M3x8s. I mean, with those actually, this should be fine. We don't need to countersink if we use those screws. But my idea was to use, I mean, that's too long now. We need to quickly grab another one then. It's to use this black countersunk screws because it will look a little bit nicer from the top. But it's like, it's the underside of the printer, so it's all a bit in vain, I guess. See, where is my green Allen key? Oh no, we need the green one. Okay, they're a tad too long, but that's fine, it's just temporary. I would say this works. Like it's on quite securely. The only thing is like what I noticed, like if I loosen the screw, like it flexes a little tiny bit out. So it might be off here by like 0.5 millimeter or something if I add now the other side. But that's fine. I guess it's like not fine for my ego, but overall it would be fine. And also like those screws we can totally use. Like if we don't want to countersink that, we can use those screws. So let's do the other side, I guess. But let's remove that so I can like properly align it here. Okay. Let's quickly collect the screws. So I guess all or nothing. It's number 1. And number 3. No, I have cling film wrapped around my drill bit. It's a later problem. Okay, let's get it out of the way. Man, I'm muted again. I'm so sorry. But this time I think I forgot to unmute. I was saying like they do not merge together nicely. See? Oh, that's my headset. Let me quickly set it up again. I'm dreaming of the day when my headset says like, oh, 10% remaining. Then I could switch it, but no, it goes like from nothing to, or like from working to not working in a split second. Okay, so I'm not quite sure if I fucked up in Fusion, but there's some gap. I mean, everything's fine, but there's a gap. Which I wonder why there's a gap. Let me just double check, but I mean, that aligns. Okay, so that's fixable, of course. Not super important. Like what I can do is I can either just add like a little pillar piece here in the middle, which maybe would be nice anyways, that I can have something that overlaps a little bit left and right. Yeah, so that's a little piece I can add. That's not a big deal. But then basically this one also doesn't align. Oh. Oh. What is going on here? The white parts fit perfectly. What about the covers? I would also say the covers fit perfectly. Oh no, the covers have the same gap. Okay, yeah, I'll fix that. I will add a small piece in the middle. That's not a big deal. But I really wonder where this is coming from, because in Fusion it matched up perfectly and I mirrored the sides. And I do wonder, I mean, most likely the white ones, they have a little bit of flex, and that's why they, like here, line up perfectly in the middle. But if you press them apart, then there's the same gap. Okay, well, that's a shame. But I guess we can still continue. And worst case, I patch it up with a tiny piece of tape there. So basically, how is this supposed to work? So my idea was now, we have this like end pieces here, and I kind of have the grand plan to extend this further back at some point, but for now the front is fine. So I just made this like as a like separate module basically, so you can extend them to the back. I'm lucky I didn't do that here because then it wouldn't work at all. Yeah, but basically this cap is made to house a JST connector. And then basically we will glue the LEDs in here. So we will solder the JST connector to the LED, then we will glue it in, and then we will fill the JST connector in here and put it down. That is my grand plan. So let's see if we can make that happen. Yeah, let me park this to the side for now. It looks cool. I think, like the fan hub here, and then, I mean, minus this little gap here. And then just imagine this now glows in color. Let's see if we can make it happen. Cool. So these are the LEDs we want to use. The only thing that I kind of did wrong is a very strong word here. These are not the typical LEDs you get. They are, but it was a small twist. These have 4 connectors, and these are WS2813 instead of 2812. The difference is that they have a redundancy in the paths here. So basically with the 2012, right, if one LED burns out, the entire strip afterwards is gone. With the 2013s, they have redundancy in terms of if this LED dies, there's a second data link that bypasses the LED. So the next LED still gets a signal. So they have redundancy basically built in. And I was like asking on the Voron Discord how to connect them, and also what I found online. So basically what we do, let's cut that heat shrink. So what we do is for the first LED, we will connect the redundancy pin to ground. That is basically the only difference, and from there on it should be fine. Oh. So yeah, we will also power them separately because the SKR Mini E3 is only rated for like 5 LEDs basically. Unless you put on this like special module thingy, then it's 30. But yeah, we just power them externally. So I'll just unsolder those now. Then the DI data in is what we need to connect to the board, and BI is the redundancy one which we connect to ground. That's my plan. The only thing that we need to do is I would solder now the connector, and once we have the connector soldered, let's do a test run before we like put it all together and plug it in, just in case that we mix up BI and DI, because I'm not 1000% sure on that. Technically, I mean, we can also, like, before we solder, right, we can just really try with this connector here. If we crimp a JST on that, we can test it quickly. So I would use my demo test board here, which in case we have a short or something is not as bad. So we have the NeoPixel port here. And we have 4 cables. So basically one of them, which is the green one. The green one needs to go to ground. And those, let's just crimp them on a JST here. And I think the order is correct. We just double check that. Crimp it to a JST and then just try to control the first LED. Like the first 2. Just try to control the first 2 with that board. And then we know that the setup we have works. And then we can solder like a nice connector to here. So let's quickly do that. So you got my crimping equipment. And then we need a 3-pin JST. couple of those. And the green one, let's just then put them to some random ground on the board. Let's first crimp the connectors, and then, or like crimp the pins on the connectors, and then we'll figure out what goes where. Let's just start with the green one. They're very easy to crimp, that's nice. So if I don't regret saying that. Instant regret. I almost destroyed the ground cable. Yeah, it's okay. I noticed that I had... Oh, you don't see anything I'm doing. That's sad. Almost pinched the black cable in the crimping pliers. Okay, all four are crimped. Put it to the side for now. And let's quickly check our pin out. There's a SKR Mini E3 V2. I'm pretty sure that the right one is the power. Yeah, so yeah, exactly. The right one is the 5V and center is data. So looking at this connector, right one is 5V, center is data. So now the center question is, my assumption would be it's DI, which is yellow. And then ground is the left one. That leaves us with the green one. Let's just see if we find like a convenient ground pin, which would be, for example, the X stop on the left side. Just grab a X stop on the left side. So this one then goes to the X stop, and this one goes to the NeoPixel port. And then this is connected, and we have some random accelerometer lying here. Let's ignore that. Then what we need to do is let's hook up this board. And let's make sure that these don't touch. That's actually like a good one. Yeah. Problem solved. Let me quickly be nice and shut down the Raspberry before we violently. Oh, there are some marks. Did I do that today? Maybe. Huh. Okay, let's power it off. I'll just keep it laying here on the side. The only thing we really need to connect is two things. We need to connect the 24-volt cables for this extra mainboard. And I'm using the extra mainboard in case I have any issues. I'd rather fry this mainboard I can expand than the ones that I have in the printer. So this is 24-volt connected. And then what we also need to do is, see, I'm running out of space here. The other thing I need to do is to connect USB. So let's just steal some USB here. So now this mainboard is basically connected to power and to USB. And now what I will do is to do it, as always, quick check that we don't have any ground, which we don't. Don't have any short, not any ground. Okay, it looks good. I mean, okay. No shorts. No shorts are good shorts. Then here you have the full overview. Everything looks good. See lots of LEDs. Let's quickly wait until this comes online. Perfect. So I do have this kind of already configured because I quickly tried something else out with LEDs during the week. So I do have this NeoPixel underground here, which is exactly what we need. But the chain count I just limited to 2 for now because we can't drive so many LEDs via the integrated voltage supply. So this should be fine, right? This is we can also quickly double check that. This is the SKR Mini E3 V2. And this is the PA8 NeoPixel pin for data, which goes here. And we have chain count of 2, and initially we just say red. Oh, we have an error. Oh, my bad. We forgot something essential. So I have to add the V2 MCU back. So now we have 3 mainboards and the Raspberry. And we have 2 red LEDs, which you can barely see, but you see the red. So this works perfect. So we now know that basically the green cable, which is BI, just goes to ground, and then this works. Perfect. Cool. Then let's shut everything down. And let's start soldering some connectors. Oh. Yeah, well, that means we need to desolder that, right? Let's just grab that strip on two spots. Let's see if I get my solder iron organized around here. Might be a bit short, but should be fine. Oh. Still heating. See. Let's just start with this one. Oh. It's not really nice. Ah, the other ones are easier. Okay. Okay. And we're left with 4 nice pads. Very nice. It's always a bit tricky. Like the 30 ones have big, nice pads. The 30 like LDs per meter. But the higher density ones are always a bit nasty. So we need basically something like this. Where did I put the channel? Oh, it's mounted, of course. Let's see. So basically, looking at this, the connector goes here, basically, or it doesn't matter which side. So basically, we need to see. This side is actually better. I mean, it doesn't matter. Let's do it on this side, because on that side, there's some AC wiring. Let's put it here. But so basically, we have from the start of the strip, which should be here, like, let's say, like 1.5 centimeter cable to the connector. Like 15 millimeter cable. There's a bit of space which is hollow. I had a bag with like random bits of cable. Let's just use some cable from our like random collection. I don't think there is anything good here. And we can use this one. Oh. I wonder whether we need any special cable. Like this one is 22 gauge. It will be around like top 3 amps, I guess. So it's like 22. Let's see. That's not what I wanted to have. There's this like fancy table. This one. Let's just use this. Like it's a really short wire thingy, so it doesn't really matter. Yeah, they say 7. So that's well below what we have. No, they have power transmission. I wonder what I need a way beefier cable than I think I would need. I mean, what came here is 20 gauge. But we will have way less cable. So 22 should be fine. Let's go with 22. 22 is fine. I wonder. Yeah. Sorry. 1 second. I wonder whether we should also go for different colors. It's like a very short run, so it doesn't really matter. But let's just be proper. So this is on. Then I mean, it's really not a lot we need, right? And then we also need a second cable here, right? To as a jumper to BI. Let's maybe do it the following way. Let's do it the following way. So let's try to isolate a bit off somewhere in the center, like this. And then again on the end. Okay, so now I have a bit of wire with a gap here in isolation and no isolation at the end. And now what we can do is we can make this as a loop. So basically we solder this here to the BI, the end, then this one to the ground, and then this goes to the connector. We don't have to deal with like soldering like 2 wires to one of those pads. So now let's actually put a little bit of solder already on that bare section. Yeah, So now we have it like connected to the DI and to ground. And now we can solder the DI in the middle. Maybe we should have done it first, but what would be fun without a little bit of a challenge? This there without touching. And we have our typical 3 wires out. So let's see. So we said like 1.5 centimeters. So I guess something like this should be sufficient. Let's remove a bit of isolation again. So, and then let's put tiny bit of heat shrink on the center one. Just so we can prevent it from like touching later on. With just a bit of challenge to solder. Cool. Then, yeah, maybe let's throw a little bit of tin on the tip first. And I guess it doesn't matter which direction, but let's keep it consistent with what the mainboard has. Let me just plug this in here so we now kind of know the orientation, how it goes on. Okay. Then the last one. No. That doesn't want to. Let's stretch it a bit. Yeah, now it's better. Perfect. Now we can just put the heat shrink over the center pin, and then we have a bit more isolation there. Not really required, but just for good measure. Cool. And this is our final product. So then let's quickly clean up, because I think that's all the soldering we need to do for this LED strip. Yeah, let me quickly just clean up teeny tiny bit. And then we can start installing this LED strip in our channel. So basically, now looking at that, I mean, it doesn't really matter. Like, the problem is in the printer, we need to grab 5 volts from the Wago terminal here, but we need to have the LED over here. So I guess the best one is to kind of route it this way. So we will start our LED strip on this side here. So that means we glue it to the inside. So this needs to have this orientation here. See that we can kind of push that in here. And then I think we should secure this with a dab of super glue later. But yeah, there's not a start of the strip. And we did a very good job estimating the wire length. Yep. That's on. And then basically we can now like start putting this in here. Let's just remove the end cap on this side for now. Yeah, so that's basically the length we will need. Now I'm wondering whether we should have this extra LD or not. I guess let's do it. So we cut the strip here. There's my cutters. What did we now say? Here, yeah. Perfect. I guess let's glue it. Okay, I'm just removing the backing of the double-sided tape. And then I guess we can just step by step just install it. And I'm just trying to make sure that we kind of keep it on the same level, like vertically. And if anything, I want to trend down then up, because on top we will have the lid basically for the cable channel. Just see a bit closer. Extra LED is a little bit too long, but I think we can just cut this. We don't need that. But I want to keep the end connector, I guess, in case I want to reuse this LED strip for something else in the future. But I think we can just wiggle this into the end cap here. Let's just keep the backing on that last bit. Yeah, perfect. And screw it down. Perfect. So we now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 LEDs in this run, which is pretty nice, I think. Very happy. Let's see if this works out once we turn it on. Where did I put now the... Oh, here. So now the reflectors basically go on. And then the lid goes on top. And if we now wouldn't have this like nasty gap there, I would be really happy. See, this needs a little bit of convincing sometimes. There we go. Yeah, there's like a 1 millimeter gap in the middle, which is, I mean, it's not terrible. And to be honest, I most likely will just throw like a little bit of tape over it. Cool. Then the only thing we now need to do is to crimp a cable to connect that. Oh, no. Wait a moment. What do I do now? I'm a genius. It's on the wrong side. Oh. Didn't we say we want the connector here? Now we have the connector there. But now the connector stays there. Not gonna change it again. That's okay. Okay, nevertheless. Let's do a cable. So looking at our printer, so we need to route from somewhere here over to this cable channel. One cable goes then here and the other cables go here. From our color coding, and I want to stick with that, the yellow wires are 5 volt. So what I will do, we will use, double check, I don't have any ground wire in there anymore. Nope. I will use black cable for ground, of course. We need yellow cable for the 5 volt signal, and then I will use blue, I think, for the data. The only thing we need to do is, or what I want to do is, I want to have one ground going to the main board. I'm not sure if that's smart, whether we should ground it to the main board as well. Like the ground is all common anyways. I just don't want to have the 5 volt flowing, or like the power, the amperage flowing through the main board. Maybe I don't ground it to the main board. And then we set blue for the signal. So let's make sure that we have enough cable. So the ground one will have to travel all the way around. So I'm just taking it very roughly, something like this. The yellow one will have, let me just quickly check, does it make sense? Yeah, it looks like the same length. The yellow one will have the same. And yeah, let's just do the blue one, same length for now as well, but then this one will be shorter later. Oh no, let's, because this is a separate run, let's also do it for the proper length already. Something like this. Down here and then over there. So that's the back. Cool. Then let's crimp a connector with that. So on one side we will have a JST, 3-pin JST, similar to what we have here. And on the other side, only the blue one will go in a 3-pin JST in the center position. So let's just start with the one that they have all in common. Let's hope the crimping gods are in favor of this crimp. That's one. Still on the fence with the ground. Oh. Second one. Now the question, 1 or 2 ground wires. We can crimp 2 together, I guess. Nah, let's keep it separate. Okay. Then 1 more to go, which is the opposite end of the blue side of the blue cable. And that's it. I need 2 housings. So the blue one goes in the center of both. That's very simple. Then let's compare to this one. So basically the black one goes on this side. And the yellow one, which is our red one here, goes on the right side. Perfect. And then on this end, basically all we need to do is to remove the isolation for like 11 millimeters. Because they will go into the Wago. And let's do the following, it's just to test it up. So at the moment I don't have a free ground, so we have to kind of combine it with something. Let's just combine with our temporary mainboard for now. It's not perfect that you put two cable in one Wago, but for testing now it is fine. Okay. Tuck test, tuck test, tuck test passed. 5 volt, we have plenty of free spots. Oh, so that gets a tuck test. And then we connect this lone data pin to the NeoPixel port on the spare mainboard. And this end goes into our strip. It would go into our strip. But I can't push it in. I think we need to throw a tiny bit of glue on here. Otherwise that won't work. Because if you push in the connector, you push it just back. So yeah, let's see how we... That was not super smart. We should have done the glue first. Let's see. Let me quickly grab my glue. I'm low-key afraid to like smudge some glue all over my beautiful panel. Let me just protect it a bit. But then my idea is just to use this like a brush type. Hopefully just reach all the way in there. Not sure if that's a trick. Where did I have my... Yeah. There's glue. I managed to put the glue all the way in. I didn't make a mess. Okay, let's quickly let that dry for like another 30 seconds. And while this is drying for a second, let's quickly do like a short test, as always. Check. No short here. No short there. No short there. Okay, then let's plug it in. Come on. Okay, it's plugged in. Let's do another quick short test. No short there. Yeah, that's already like all I needed to know, right? So, let me see. Let's turn this on and see if technically 2 LEDs should light up right away, like after Clipper booted. Well, here goes nothing. 3, 2, 1. No magic smoke. We passed the minimal hurdle basically, or like we passed the minimal goal. Let's see. So let's give this a second to boot up. Yep, I already see like there's red. There's red. So that's good. How many LEDs did we count? 17, right? So let's just put that as our configured length. And we have, well, that's the wrong color, which is a bit odd, but I guess it's just, yeah. Oh, oh, you don't see it all. Here you go. And yeah, you definitely see the individual LEDs. But I guess like that's like more due to the density of the LD band strip. I forgot the word strip. Amazing. The other one I had in before, like as a test run, was the 60 LDs per meter, and yeah, basically in between each of the spots there was like one more LD, which made it like darn close impossible to see the individual LDs. I also now realize that those screws here that we used now will also be used on left and right to hold this down. So I'll definitely keep them here and not use the countersunk ones. Yeah, let's put in the wires. Like, let's shut off, put in the wires where the wires need to be, and then let's see how it looks from top. Let me be nice and shut down the Raspberry as always, almost always. Sometimes it's not so nice. Yeah, and this goes then like this. It looks nice. Let's cut the power. Let me wiggle out that JST. Okay, we then also need to configure the other mainboard, right? So let's remove that temporary mainboard from here. And also this one. So let's see. Yeah, so this one we can completely remove. The only thing we need is our brand new cable. Clean it up. Second. Okay, then I used to have those like really handy like clips for cables, but I don't think I have any left. I need to print new ones. So for now, let's just hang this here. then basically this, this goes in here. We need a little bit of cable, something like that. Let's actually put this on this side. And the blue one is already way too long, I can tell you. So this one needs to go exactly here. I'm actually considering whether we should shorten that a bit. Let's see. Let's quickly put in the cables where they should end up, and then like route them just in. So this needs to go to the ground down here. And this one needs to go to 5 volt down here. Quick tuck test passed. This is the most messy part of the cabling. Let me see if I can. It's a bit better. That was a bit too close. So let's just put this through here, and then let's just move it up. See? Try to get this back on. And it's on. And let's remove the middle part. Okay. Then, yeah, the blue one is way too long. Let's get this out here. Kind of tuck that here on the side next to the stepper wire. And this basically just goes through here. Okay. That's just my goal is to get on the lid. Hopefully. Here we go. On. Okay, and then the blue one we need to figure out. Like this is way longer than the other ones. No, it's not. The other ones are longer. Woo. Okay, but we can now pull the cables a bit, so it's not a big deal. So the blue one is seemingly the shortest one. I want to have a little bit of slack here, but this is a bit too much slack for me, to be honest. But it's fine. We can also wind it here. Because the moment like you pull off the panel, right, you want to kind of have a little of like wiggle room. But then let's pull some of the yellow cable. Let's see if we can gently pull it. It's the same length as the blue one, which is not the case. So we can remove a bit here. Let's just do that. Something like that. Strip another 10 millimeters, and this goes in here, and we have a perfectly sized cable. Then this one is the black one, right? Let's also try to pull this one a bit back. Now it's also the same length. Let's do the same here. Just this. And we have a perfectly sized cable. It's a bit too long overall, but yeah, we can make a loop somewhere in here if it's really like way too long. Shall we do that? Yeah. That's actually not. Because again, like, we will have to like mount it somewhere up here. But I don't have any more of those clips. I saw one recently. Let me see, is there something in here? Nope. Okay, too bad. Then let's just use a zip tie. I know I have zip ties. This is like a to be replaced solution, but I'll just zip tie it to the earth cable. Cool. We could have also twisted that a little bit, but here's the thing, like potentially if I pull this off, I also just sleeve it. I have like a lot of cable sleeve. I mean, if I shorten it a bit, in case, then I just sleeve it as well, and just have a sleeve come out of the cable channel here. Looks a bit nicer, I guess. So, but let's not waste any more time. Let's actually put it up. See, I can kind of like show you what's going on. I guess the grand moment is close. It's not horrible that it's so long. We just need to kind of like manage it a bit here. See, there's a nice little cavity like next to the power supply where it falls into. And this is our new LED strip. Nicely routing around everything. Let's start by adding the 2 screws here left and right. I still have a little bit of like tension when I put on the bottom panel, like it doesn't align 1000%. I'm not quite sure why, but it goes on. You just have to convince it a bit. It's 1 screw, 2 screw, 3 screw, and 4 screw. Also give those a little bit of a tighten. And that's it. So not 100% sure that a clear bottom was the right choice, but I mean, it looks pretty. I think I'm quite proud of my cable management, so doesn't look too bad. So now the question, if we turn it on, well, wait, something's wrong. Something is wrong. That's the fan and that's the fan grill. That is not how to choke a fan, put a panel directly on top of it. Yeah, we quickly have to flip that. Oh, shit. I was so happy. So basically we mounted the LEDs to the wrong side. Okay. Let's see. Yeah, that's what I mean. Like this one is a little bit like stiff. Like it's not easy to pull out, so it doesn't align properly. Okay, let's see. It's not a big deal. Yeah, it's good if we have that cable here. It's just like, because it's loose strands, it's a bit weird, but maybe we can find a solution for that. Okay. Let me see, can I move that a bit to the side? Basically, you just have to quickly undo those 6 screws and move the LD channel to the opposite side. Still annoyed by the gap here. See, good, we didn't glue it. Because then we would now have a problem. I mean, I could cut a second hole here, but then it's kind of like not really the point of it. Luckily, very easy fix. But it also reminds me we should glue the fan grill, which we didn't do yet. Low-key afraid of that. I think it is about time that we do that. Here it is. So I'm happy with the design. Just make sure it's like properly oriented. And then what I would do, let's cover the surroundings a bit, because I'm expert in making a mess with super glue. Let's just very carefully add a little tiny bit of glue on the seam. There's some 2-3 spots. Nothing crazy. That's really all it takes. No mess. Yay! Okay. Now it looks better. Now the fan grill is over the fan. So, add everything back up. Okay. Where it belongs. And then I think let's see whether the LEDs look any good. Would be a shame if we now did all the work and it looks horrible. I'm really excited for that. I was like designing this LED strip like the entire week. I was like done by like Wednesday. It wasn't the entire week. And I really wanted to see how it looks like in reality, and now it's finally here. And minus the gap in the middle for a millimeter, like I'm so far happy. Let's see if the light effect also looks like what I expected. Okay. Let's turn it on. Oh. Oh, I'm so stupid. I forgot to plug it in. Well, this speed, like we're still busy tomorrow. And again. Luckily, it's only 4 screws. And here we go again. Let's see. So it's plugged in, band grid's on the right side. Nothing can go wrong now. One, two, three, 4. Here we go. Last screw. Okay, let's turn on. 1, 2, 3. And then basically once Clipper booted, we should have like a nice red LED ring here. Let's hope everything goes well. Takes its sweet time. Oh, I'm waiting for something that can't happen. We need to update the configuration, of course. Because now we are on a different mainboard and also Clipper won't start up, right? So we need to comment out our like temporary like extra mainboard here. And then now we need to figure out on the SKR Mini E3 V1.2 pinout. So here we need to check for the NeoPixel pin, and this is PC7. So we need to change the NeoPixel config for the underground from V2 to V1 and from PA to PC7. Double check PC7, yeah. Save and restart. And we have success. See, I just hope it's bright enough. That would be a real bummer if not. I mean, we can always like swap in for a strip with more LEDs because this is like 17 only, right? I also have 96 LEDs per meter, so it's like 3 times the density. But then we need to have a bigger buck converter. Let's see. Let's flip it over. No, I'm not sure if this looks like what I expected it to look like. I don't see much. To be fair, it's very bright in here. Let me quickly turn off that monstrous light up above me. Still not very, there's still a second light. That's how you see it on one side, but still not super bright. I mean, there's some glow. Let's see. Let's play around with the config a bit. Firstly, let's check Yeah, I mean, like, this is only the red LED, so if we put it to bright, like it's white, of course, like it's more LEDs. Let's see, let's just integrate them into my macros. So my idea was, so I quickly showed that before. So I have the light printing, which my idea would be to copy the color code, which is like this yellowish, to match the theme of the printer. We need to remove the index here. And this is underground light, I think. And then for light off, we just turn it off, of course. And then for light pending, we set it to the same red. And then this is 0.02. Save and restart. And we still need to change the initial value though. So now if I do light printing, oh, that's light pending, so everything is red. Yeah, so you also see the, do you see that? That's the tool height. So everything is red. Then we have light printing, where this doesn't do anything, so that's not good. We need to check. Underground light is not a valid LED. The name is wrong. Let's see. Oh, it's just underground, but then let's just call it underground lights. Just to be consistent. Oh. And then here it's also underground lights, underground lights, underground lights. Okay, let's try again. Yeah, now it also turns automatically off because it's part of the macros. So this is light off. It's off. There's only like a little bit of green here. Then we have light pending, which has a bit of like the printed illumination we just added today. Red and red. And then we have light printing, which has a lot of printed illumination and has yellow and yellow. Now I'm not sure if you see it. I mean, there's a bit here, but that's, I expected a bit more. So I'm a bit sad. Not gonna lie. Not gonna lie. I mean, it's nice, but I expected a bit more. So I guess, I mean, I don't have them here right now, but I have higher density LED strips. Then I guess that it would be like the route I would go to just have higher density LED strips there. That would mean, so here's the problem. Problem is a bit of a hard word, but at the moment we have 17. We have 17 LEDs, and each LED uses 60 milliamperes, 0.06. So this equals 1 amp. If we now double, like triple that, so at the moment we have 30 LEDs per meter. If I would go up to my other strip I have, which is 96, I would have, let's say, roughly triple. So let's just say around 45 LEDs. Which is 2.7 ampere. And then we are kind of like really close on what the buck converter can do. Because the buck converter that powers that 5-volt rail, I think they're rated for 3 amps. Yeah, it's like one of those like stupid ones. And I think they have an output voltage of like 3 amps. Does it say here somewhere? I have no clue why this is Dutch, but this is like 3 ampere out max. So that's exactly like then the kind of like what we are doing, right? Because we are now at then 2.7. So I like a bit uncomfortable because like the 5-volt rail also drives the tool head completely, which needs some extra 5 volts. So that basically means that I would need to add a third buck converter, which is fine. Like we can do that. We have space and we have plenty power. Like the thing is like from a watt perspective, it's not a lot, right? The problem is just because 5 volts, like you end up with a lot of ampere. Like flip it over again. Yeah, I mean, what I can also do is like I can reduce, because at the moment I have this transparent patchy, like here basically it's covered by transparent patchy, and I think this is 3 layers. So I can remove that, of course, completely. I can't remove it completely because then my design doesn't work at all. But potentially I can reduce this to 1 layer. Yeah, so that would be one solution. I mean, it looks cool. It's just not really bright. So yeah, I think the solution would be really to like swap the strip out for a strip with the 96 LEDs per meter. And then you would have like 3 times the LEDs and 3 times the brightness. But overall, I think this looks really cool, like with the transparent bottom. And yeah, there's space for like another buck converter. We can totally make it fit. The design for this like little thingy here is from me. And I can just extend it with 1 extra one. That you have like, instead of like 2, you have like a third one there. Then we can just put 2 in parallel, which would give us 6 amps. I mean, technically what we can also do, right? Like the idea here was that 1 provides exclusive power to the Pi. Which I think is, yeah, I kind of want to keep it that way, that we don't have any power fluctuation on the Pi itself. So this top one only does the Pi, but then the bottom one does like everything else, which is a bit too much then if we like up the LEDs here a lot. So yeah, I guess that would mean we have a third buck converter. Yeah, cool. But I'm kind of like done with all the things I wanted to do today. So we have the lights for the print bed. We have this very low-key underground glow lights, which doesn't do much, but it looks cool. Yeah, that's pretty much it. So I have a couple of to-dos though that I need to clean up, right? Like the belt tension is completely messed up right now, but I need to figure that out in a bit of peace. I need to print a couple more of those like cable clips so we can clip the cable here on the side. I think the length is quite good now. Like it's quite long, but you don't really see it like flopping around back there. And then like when you take off the bottom panel, like you have a lot of cable to work with to unplug it. But it looks nice. Like I'm happy with the looks. There's still this gap in the middle that bugs me. Yeah, but given that it's not super bright, it's not a big deal anyways. Yeah, it's cool that we can control the brightness of the print bed lights. But it's also like something positive. Nice. Yeah. I guess that would be it for today. Yeah, no, that's it. Cool. Then thanks everyone for tuning in. I see like a couple people are watching. Next week, maybe quick word, we do the Nomi. So we'll have like a small display on the printer. So this will be fun. And I will also customize the software for the Nomi. That will be like, installation should be like relatively straightforward, I guess. But then basically we want to customize the animations here, the colors. So that will be fun. If you're interested, next week, same potentially Saturday, maybe Friday. But yeah, that's more spontaneous then. Cool. Thanks for tuning in and have a nice weekend, I guess. Bye.